Hi everyone, let's continue one more session on smatpls4. In this session, we would learn how we can run confirmatory factor analysis. So let's begin. A moment I'm going to open my PLS smartpls4 interface. So now we can see here is I'm going to create a new project, and in this project I'm writing CFA demo. CFA demo. I had created this CFA demo. And now what we have to do, import data. A moment I would click here, that is my data is put it in the YouTube smartpls4. So demo data, I'm going to connect it here, and this data, it is visible. And now import this data. A moment we will import this data is visible over here. Now what we will do, we will go back, and now we are going to create a model. And when I have clicked here, so here is project name is CFA demo, but what you are going to choose. So because I'm doing CB-SEM based, this is confirmatory factor analysis. So I had selected CB-SEM, and here is I'm giving the model name confirmatory factor analysis. And let me save this, and I had saved. Now these are my constructs items. So in my study, there is total 4 constructs. So let me create all these 4 constructs. So RA1, RA2, RA3, RA4, RA5. Let me drag this, and RA, I'm not going to rename this because that is for the demo purpose. So same name, I would put it here, and I would press OK. And moment I said okay, so it is like this. And now what we have to do, in my previous video, I said how you are going to rotate this. So moment you are going to click here, right click, and here is you can see align indicator to the top, align indicator to the left, align indicator to the bottom and to the right. So this was the one way. When you are going to click here, these indicators are visible here also. So let's say I want this one is towards the left hand side. So I had aligned towards the left hand side. Next construct is CT. So what are the items? How to measure CT? CT1, CT2, CT3, CT4, CT5. Let me extract this, and same name I would put it here. And now I am going to align here. Again, I want towards the left hand side. Now I would come to the one more construct, that is CX1. That is CX1, 2, 3 and 4 and 5. This is my one more constant CX, and this is the total 4 items. I'm going to measure this, and the last construct is T1, T2, T3 and T4. This one is, I'm giving the name as TI. Okay. And now these are my 4 construct here. Now what I am doing here, that is CFA, confirmatory factor analysis. So there is the sign you could see here, correlation. And here is correlation. I will click here. Now both side arrow you could see here. Now I'm going to connect all the constructs. So this is, so I'm going to connect all the constructs. So now you could see all the constructs are connected. Now we will go to calculate CB-SEM, and here is, you could see here, because covariance structured equation modeling, CB-SEM is a based approach to structural equation modeling SEM. However, this supports common factor analysis and allows the estimating and the testing of the models with the latent variables by using the observed covariance matrix between the indicators. So let's start calculation. And now moment you are doing calculation, all the values are visible. And now what we have to do, weights, and we have to take weights loading standardized. And moment we have done standardized, now you can see how we can cross check this. All the values are less than 0.7. Greater than 0.7. So 0.854 on all the values are greater than 0.7. So that is acceptable. we will go to model fit. I want to see model fit. So this is the model fit. We will interpret also this model, but not in this session. I will tell you how you're going to interpret and how you're going to report in your article or in your thesis. So chi-square value you could see 140, and this is the null model. It is well accepted. I will share with you how you are going to compare number of the model parameters, number of observations, degree of freedom, p value that is acceptable, and chi-square value 0.961 RMSEA, that is also as comparatively to the null value, that is within the range. RMSEA low 90% confidence interval, high 90% confidence interval. GFI you could see here, that is greater than zero point 0.9. AGFI also, that is greater than, and all these values are acceptable. And now you can see I have reported here how all these values are. You could see here. This is, I'm going to share in my description box how you can measure. So let me, you can see here chi-square, my obtained is 140, lower is better because interpretation is non-sigma indicating good fit. Chi-square by degree of freedom, that is 0.961, and that is less than 3, and excellent fit because it is lesser than 3. P value is 0.617, that should be greater than 0.05 because that is the good fit. Interpretation is good fit. Model is not significantly different from data. RMSE here is in 0, but it should be less than 0.08 or 0.05, right? If it is less than 0.05, so that is excellent. So my model fit, it is excellent. RMSEA value is also reflecting, and GFI 0.936, that is good fit. It is greater than 0.90. AGFI 0.917, that is greater than 0.9, good fit. And PGFI, that is greater than 0.5, and it is 0.72, good and parsimony fit. SRMR 0.039, and it is less than 0.08. It is excellent fit. NFI 0.947, it is greater than 0.90. Preferably, it should be greater than 0.95. Very good fit. And here is TLI 0.003. Only this is the little bit higher than, because it should be greater than 0.90, preferably greater than 0.95. Should be up to the 1. It's little bit higher, and it is excellent fit. CFI is 1, and it is greater than 0.90. It's excellent fit, and preferably it should be greater than 0.95. AIC 228, lower preferred and useful for comparing competing models, and BIC, and there is 376, lower preferred, useful for comparing competing models. So in that way, we can find the threshold value, and we are going to compare all the values with this. Then we come to the construct reliability, and construct reliability, you could see it's very good. Cronbach alpha, that is all are above. This one is the Cronbach alpha, that is the standardized. It should be more than that is 0.9, or somewhere it's 0.7. Average variance extracted, you could see here, because that is for the validity. This one is the validity purpose, and all AV value are greater than 0.5. All are acceptable. And when we will go to discriminant validity, so here's HTMT criteria. You could see here HTMT criteria, and that is discriminant validity, HTMT, or Forner-Larker also you could see. This is the Forner-Larker, and Forner-Larker you could see that is the square mean of AVE. That is acceptable. And when we come to the HTMT, and now this is the HTMT, that is also acceptable. And I'm sure now again we will go back. So this kind of right, I'm going to explain in the next video how you are going to report in your publication article or in the thesis. This is just the interpretation of this and how we are going to create. So I hope this video would be helpful. Stay tuned, keep watching. Thank you.